Hey everyone, thank you for coming to this week's Rising Tide Foundation lecture, where we are continuing in our theme of science unshackled. Obviously, one of the repeating ideas has been this notion that the mind is more than simply the power to use memory or to learn by rote, by repetition. Of course, these could be useful things, and in wise hands are useful techniques, but they're just techniques as part of a greater process which, when done responsibly, uh, must tie in the mind to the universe in a form of eurekas, in a form of discoveries. In ancient times, this was better understood during the period we have examples in ancient Greece, in Egypt, and many other cultures where there was a focus on spherics. There was an understanding that the geometry that we constructed and used on Earth was tied in some way to discoveries that were made regarding the cycles of the planets, of the heavens, and the different geometries that one could glean from just sort of situating the Earth and our field of vision within the Earth, looking upon the night sky and the stars, as though we were looking upon a sphere, an orb around us, and mapping things onto it and discovering there are certain relationships, right? Certain angles that are more interesting than others, certain repetitions in time and in space that are more interesting than others that the mind could zero in on and discover a sort of a quantization. In Kepler's time, or in Plato's time, he did a lot of work on the Platonic solids to look at the quantization of the many that bound or find themselves between the one and the infinite. So surprise, surprise, this is not simply a European phenomenon. It's not something that simply emerged out of Egypt that was the seat for the rise of what we today call Western civilization. Pythagoras, Plato, Solon, all studied in Egypt. But these are universal ideas, universal discoveries that we find also arising in places as far as China, in ancient China. And Quan has really done a lot to help me appreciate a lot more of those dynamics and subtleties of ancient China that has allowed this civilization to endure for thousands of years in ways that I think are very unique and very special for the current age and the future. So with that, Quan was gracious enough to agree last minute to deliver this presentation. We had something else scheduled for today, but the speaker fell sick, and Quan was more than happy to present something on the topic of science unshackled, which will round out our cycle. So with that, Quan, thank you so much, and the stage is yours.
Thanks, Matt, and thanks everyone for coming this afternoon. So today, as you saw in the title I sent, is Mathematicians, a Musician, and the Music of the Spheres. I want to start with what is called the Jiu Jiang Shuang Shu, which can be translated roughly by the 9 chapters of the mathematical art. And that 9 chapters of the mathematical art was a book with many authors, and those authors lived between 1050 BCE roughly to the 2nd century BCE. So we will start with one of the first authors in 5 minutes, but I want to take 5 minutes to have a kind of overview. When we think about the concept of classics in China, the Westerners who made an effort to know a little bit of China would think to the 4 books and the 5 classics, right? The 4 books are the epistemological treatises of the Confucianist School, and those epistemological treatises are the Tashui, the great learning. And once again, great learning is not about information or about technical skills, it's about being. And the Analects, which are the selected sayings by Confucius, the Mencius, the book on epistemology, universal history, politics, rhetoric, economics, by Mencius, who was born in 372 BCE and who died in 289 BCE. And finally, the book by Confucius' grandson himself, Zhu, the Doctrine of the Mean. And it's interesting, the word, the doctrine of the mean, because most of the time, epistemology is either related to natural sciences or associated with what we would call in the jargon of the Western colleges and universities, the natural sciences versus the humanities. Well, epistemology is not divided in that artificial manner. Epistemology, being the journey of the soul, has application also in natural sciences and in the humanities or in political sciences. And that epistemology, precisely, when we study China from a Western perspective, I noticed that most of the time, the corpus of what is called the Confucianist is studied separately from the corpus of the people called the Taoists. And here, bear with me, I would say some of the stuff which reflect a little bit my own prejudices, but I would try to make them clear and logical. What is in China is perceived as epistemology cover political science and natural sciences. And what is the corpus of political sciences is labeled as Confucianist in the West, and what is considered as natural sciences, and which the corpus is not very known in the West, is most of the time labeled as Taoist. And I would add the serious layer of Taoism, okay, because Taoism can be sadly also associated with fantastic things, not necessarily related with epistemology, natural sciences, or political sciences. And one of those corpus related to natural sciences or to pure sciences is precisely the 10 classics of mathematics. And one of the 10 classics of mathematics is precisely the 9 chapters on the mathematical art. I want to remind that the Zhou dynasty started in 1046 BCE and ended in 256 BCE. The Qin dynasty, who created the empire, started in 221 BCE and ended quite fast in 206 BCE, followed by the 4 centuries long Han dynasty, starting in 206 BCE and ending in 220 BCE. Now, Matt, please, I would like to have maybe in the next 10 to 15 minutes an interactive session with you guys. And I would like to present the Gou Gu Ding Li, which is the Chinese name for what is called the Pythagorean theorem in the West, and has been offered in 1050 BCE by a Chinese mathematician called Shang Gao, S-H-A-N-G, Shang Gao, G-A-O. Okay, now I would ask everybody to participate. I ask you the following questions. How many squares do you see? Oh, I don't hear you, Matt.
I forgot to mention to everybody that we are all on mute by default. So if you do want to speak at any point, you have to take yourself off of mute first.
I see 4 squares.
I see 6 squares.
6 squares.
6.
That's too much.
I say 3.
3, yes. You have 3 squares, exactly. And how many right angle triangle do you see? Okay, so we have 3 squares.
Seven.
8.
Yes, absolutely. 8. Okay, so now can you see that there's a tiny square at the center, what we call a middle square, and the outside square? We all agree with that, I think. Okay. Can you see, if you see A, B, and C, okay, C being the hypotenuse, of course, that in Chinese is not called hypotenuse, but it's called xian. What do you see? What do you see? Okay, so it's A to the square plus B to the square is equals to C to the square, okay? But in Chinese, it's Gou Gu Zhu Mi Bi Sheng Xian Mi. Okay, it's equal to A square plus B square equal c square. And when you see the Chinese word, the two characters who are repeating, it simply means to the square. Okay, so the tiny stuff at the center. Okay, what do you see? Okay, how would you define mathematically the tiny square at the center? In terms of A and B. Okay, you see that the square, the tiny square at the center correspond to B minus Okay, I think
I heard John tried to say something, but his microphone is very weak.
I think I heard him say B minus A. Is it right?
B minus A all squared.
Excellent. Bravo. That's exactly that. Okay. So B minus A equal to the little square. By the way, Matt, do you have the little text that I send you to? Can you put the little text on the screen too, or if it's not possible?
I can only do one at a time. So if you want to put the text up, I can.
Okay, so let's look at the image first. Okay, so B minus A exact. So we agree that let's call the middle square. Okay, is the tiny square plus the four rectangle or the triangles. Do we agree with that? The area of the middle square is equal to the tiny square plus the four triangles. I think we all agree with that.
You're saying the area of this big square is equal to
the intermediate square.
Oh,
the intermediate square.
Yes.
Okay, is equal to the tiny square plus the four triangles, right?
Oh, yes, most certainly.
Okay, so John had defined for us that the tiny square side is B minus A. So the area of the tiny square is B minus A times B minus A. I think we all agree with that.
Yes.
Okay.
I have a question.
Yes.
B and A are points, and they do not have any length. So how can...
no, those
little
are
a and little b.
Little b. Okay, sorry. Okay, gotcha.
Okay, yes. So the middle square defined by A, B, D, E for the point, you're right, is defined by the sum of the tiny square plus the four triangles. And we define that the area of the tiny square is A minus B by A minus B. Okay, so how would you define the area of each of the triangle now?
Half AB.
Okay, 4 times A by B times 0.5, okay, because the area of a triangle is the two sides multiplied by 1/2. I think we all agree with that.
Mm-hmm.
Okay, now, Matt, okay, before I forget, the 4 characters in big that you see is precisely the title of the book, Zhu Zhang Shuang Shu, okay, the 9 chapters of the mathematical art. Okay, let's go to the stuff I sent you, Matt.
Okay, 1 second.
Okay,
like
cool. Exact. Can you make it bigger, or is it
I can
okay?
try.
Okay, no, it's okay. I get it bigger. Okay, okay. So you see that. Okay, let's start where you have the 4 Chinese character. Gou Gu Ding Li. Okay, you have the first alphabetical transliteration is the pinyin system, but the pinyin system is not very natural for Westerners. So I make a homemade transcription. KOW, so Gou Gu Ding Li. Okay, it means the theorem of the leg and the hook, because A is called Gou in Chinese, meaning the hook, and B is called Ku, meaning the leg. So 勾股密合必整线密 is exactly equivalent to a to the square plus b to the square equal to c to the square. So I put that 勾 is equal to a or hook or base, 股 is equal to b, thigh, leg or altitude, and xian equal to c, simply meaning line in Chinese or hypotenuse in English. So let's go to the place where we have the algebra. Do you have it? I don't have. Okay, it's on the other side. I would need okay, perfect. Okay, so we said that the area of the middle square is the tiny square plus 4 times the one of the triangle, because we have 4 triangles. So you see 4 times 0.5 times a times b plus a minus b by a minus b or b minus a, or and then it's not it's b minus a by b minus a and not a minus b. That was a mistake. Equal to c squared. So if you develop the algebra, is 2a plus b squared minus 2ab plus a to the square equal to c squared. So we have b squared plus a squared equals c squared. So we have the demonstration. So here, the Chinese demonstration is a combination of geometry and algebra. Okay, contrary to the typical, there are more than one demonstration of the Pythagorean theorem, of course, but the one which is very well known is more on geometric intuition, and the Chinese demonstration, which is also known in the West, is rather a combination of geometry and algebra. Okay, do everyone understand the demonstration?
I don't completely, but
Okay.
that's okay. We just keep going.
Okay.
It's
But,
okay. It's
okay.
I have to study more.
But okay, because the algebra which appears, I would just want to say, it's simply the application of the intuition we already got, okay, at the start, meaning that the whole size of the middle square is equal to the addition of the size of the small square plus the 4 triangles. And by using algebra, we arrive at the formula a square plus b square equal to c square.
Wow.
By observing the image, the image, and with the using algebra. Now we can go to the other demonstration, which is quite equivalent to. Can we have again, Matt, the image, please?
Mm-hmm. This one?
Yes. Okay, so we make the calculation for the medium square. Now, can you guys tell me what we need to do to have the area of the big square?
B plus a squared.
Okay.
A plus b all squared.
Just say it in terms of geometry. To have the big square, what do you need to add in terms of surfaces?
You have 4 triangles added to the intermediate square.
Exactly. So you have
and the side of the big square is a plus b.
Exactly. Okay, so you have what I call the medium square, meaning the square defined by A, B, D, E. Okay, you have the 4 big letters A, B, D, E. So you have that square I call the medium square. And if you add the areas of the 4 triangles on the 4 sides, you would have the size of the big square. Do we agree on that?
Mm-hmm.
Okay. if everyone agree on that, Matt, let's go to the algebra.
Is that further down here?
Yes, the thing I scribbled that I sent to you.
That we were
yes.
just looking at.
Yes, the other one. Yes, exactly.
Okay. This one?
Yeah, the one we had just had before. And I would need the second part here. Okay, so the second proof using, so I remind everyone, the first proof was using the area of the medium square, okay? And this second proof is using the area of the big square, okay? So the big square is once again 4 times the you have the 4 triangles on the outside, so 4 times that, plus c square, which is the area of the middle square, equal to b plus a by b plus a, okay, which is the side, the outside, the 2 sides of the big square. So by developing the algebra, you have 2ab plus c to the square equal to b square plus 2ab plus a to the square. So once again, we arrive at 2 square equal to b square plus a square. Or it's the same as c square equal to a square plus b square, of course. So here we have a demonstration by combining geometry and algebra. And that is one of the characteristics of, let's say, ancient Chinese mathematics, which insisted more on algebra than on geometry. It was half-half. And if we look at the ancient Greek mathematics, the geometric dimension was more important than the algebraic dimension.
Yeah, I suppose what strikes me, I'm sorry, I'm just gonna one thought to share, is that unlike the way that I was taught this when I was in high school, is that, which was purely algebraic, is that there is a geometric identity associated very clearly in the mind with each of the symbols here. Whereas oftentimes it's purely symbolic and there's no association in the student's mind of like, what does this symbol represent as a triangle, as a square within the geometric proof. So there is a connection that's very clear.
Thank you, Matt. I knew I can rely on you for that kind of absolutely brilliant insight, because what I was going to say is that the Chinese creator of mathematics, they did not proceed like Euclid. Okay, so the imaginary point doesn't exist for the Chinese. What is fundamental is the solid, the 3D object, and from the 3D object, you can have sections that can have 2D objects, and from the 2D object, you will have section of the 2D object that will give the line. And the dot is simply understood as an imaginary object and not as the starting point of mathematics. If you see what I want to say epistemologically, it is rooted in physical reality.
So just saying beyond 3D, but if we using the two algebra to bridge the 2D to the 3D and then beyond.
Exactly. The old mathematicians in China started with physical reality, okay, with the 3D objects. And getting a section of the 3D object, we go to the 2D dimension, and getting, for example, a conic section, you can get a parabola, for example, and having a section of a 2D object, you will get the line, and the dot or the point is simply understood as an imaginary object, and not like in the Euclid's demonstration, starting with the imaginary object, which is a little bit weird from the Chinese standpoint. And that was okay. So I don't need it anymore. So we can make disappear the the image, I'm coming back to my regular presentation, unless there are questions directly related to that image or to that demonstration.
Oh, so what you're saying is we couldn't have mathematics or algebra without geometry?
No, not on the contrary. We need geometry to have algebra, but the difference is that in ancient times, the Chinese started from 3D reality to go to the imaginary dot or the imaginary point. Because if you understand in the demonstration by Euclid, he started by the definition of the imaginary point. After that, we got the line. After that, we got the surfaces. After that, we got the 3D objects, okay? Epistemologically speaking, for the Chinese, it's the reverse. We start with the 3D, we go down to the 2D, then we have the line, and then we have the imaginary dot, not the reverse. Okay, so there is a difference in the epistemological journey, if you want.
Yeah, like two people could be looking at the same thing, like a physical cube, and in their minds they're looking at two very different things in the essence of it. Whereas the one person who proceeds from the standpoint of Euclid is looking at everything from the standpoint that everything is built up from the bottom up, from these non-existent points which have no dimensions that are added together to get a line, which only have one dimension, but that you add together to get a surface, which then has two dimensions, but has zero third dimension, zero height, which you add together these surfaces to get solids, which means that you're looking at an object, but in your mind, you're thinking that object is the sum total of nothing. Whereas the person who's standing from this, or looking at it from the standpoint of a top-down vantage point, recognizes that even the point is actually the shadow of reality, not nothingness, but everything can be constructed from the standpoint of something, not nothing. So epistemologically, it's very different.
Yes, it's very different. And once again, I would like to come back to the upper trigram and the lower trigram, okay? Because in the epistemological journey of the Chinese, it's always from the perspective of the upper trigram. And once again, I remind, and I would use the Greek terminology not to mix up people, but it corresponds to the Chinese epistemological understanding. The upper trigram is from the top, truth, goodness, beauty, okay? So it's always from that top perspective that phenomenal reality, or the lower trigram, is grasped or understood. It's not the reverse, okay? And it's the same for natural sciences or for political sciences, okay? Because we often repeat in Rising Tide Foundation that there is no division between political sciences, meaning rhetoric, ethics, politics, economics, etc., and the so-called natural sciences, dealing with the universe, with chemistry, with physics, and with mathematics. I would say the mathematics is maybe a little bit in between the two, because it's related with the form of the domain of beauty, which is the first of the three timeless forms, the three being beauty, goodness, and truth, or truth, goodness, beauty. Depending if you go 4, 5, 6 or 6, 5, 4, okay? It's according to your taste. Okay, so I just want to.
They could never explain coming up from the bottom up. You can't get a good picture of the incommensurability of things.
Yeah. Right. I saw a question appearing on my screen. Is did the Greek discover the theorem before the Kauku? The answer is no, because Pythagoras lived in the 6th century BCE, and this theorem that I presented you, the two versions, has been discovered by a guy called Shangao, Shang-Gao, and he lived in 1050 BCE, so about 5 centuries before Pythagoras. So, but that's okay. You can still keep on to call the theorem Pythagorean theorem. I'm a gracious person.
Thank you.
So that being said, I just want to make an overview of the 9 chapters of the mathematical art. So the first one, just to go back to the fact that the Chinese started from 3D reality, okay? Most of the 9 chapters were dealing with practical problems of real life, okay? The chapter 1 was called Fang Tian, meaning rectangular field, okay? Let's not forget that in the ancient time China, agriculture was very important. So it's not a surprise you have a chapter devoted to rectangular field. Number 2, chapter 2, it's Sumi, is millet and rice. So the calculation related to the volumes of millet and rice. Chapter 3, Cui Feng, proportional distribution. 4, Shao Guang, lesser breadth for the area and the volumes. Chapter 5, Shang Gong, measuring work. Chapter 6, Jun Shu, equitable transportation. Chapter 7, Ying Bu Zu, surplus and deficit. Chapter 8, Fang Cheng, rectangular arrays. And chapter 9, Gougu, base and attitude. So it was theoretical, but it was also very practical. I just want to mention, I will not make the demonstration. I would just want to mention that in what is called in the West, the Gaussian elimination method for the resolution of the equations of the first degree or linear degree, like x plus y equals z, for example, also known as the row reduction algorithm using matrices, has been treated in chapter 8 of the 9 chapters on the mathematical arts. Okay.
This dates
Now,
to when, Quan?
excuse me, what did you say, John?
This dates to when?
You mean the time of the book?
Yeah.
It's between 1050 BCE to the 2nd century BCE. So it's the oldest problems were 3,000 years ago or almost, and the earliest one closer to us is about 22 centuries ago.
So they were already resolving sets of linear equations in those days.
Yes, using a method resembling the Gaussian elimination method using matrices.
Oh, wow.
And this I want. Oh, thank you, John, for your comment, because I almost forgot. The Chinese invented a stuff that is called a counting board. Okay, and in that counting board, each row corresponds to a power of 10. Okay, for example, and it goes from left to right. So if you're on the left side at the 7th position, for example, it would correspond to 10 exponents 6 the million, okay? And the Chinese didn't use 0. Yes, exactly. I see the word an abacus, question mark by Susan and Doris. And that counting board will give birth to the abacus. And the Chinese didn't use the 0, however, because of the counting board and the abacus principle, when you need to put a 0, it would be an empty space. So the Chinese equivalent of the 0 marking the position of the power would be simply an empty space. So the empty space is the Chinese 0. And if you probably remember by Kevin's presentation that the 0 has been invented by an Indian called Aryabhata in the around 450 AD, if I remember. And another Indian called Brahmagupta around 650 would use the 0 invented by Aryabhata to make the calculation. Okay, question, did the Chinese always use base 10 mathematics? The Chinese use 2 bases for mathematics, base 10 and base 2. And if you look at the I Ching, it's base 2. Okay, so if there's no more question, I will keep on my presentation. So
I got a question about the numbers.
Yes.
Did they have like characters for? I'm assuming they had characters for the numbers 1 and 9.
Exactly.
Or did they have more? Or
they have 2 systems. They have the characters for 1 to 9, and after they combine them, and they have special symbols related to the counting board and the abacus for for the numbers. So you have what the numbers that we count nowadays. So in the world, you have the Roman numerals, the Indian numeral that are known in the West as the Arabic numerals, and the special system of the Chinese numerals, plus the Chinese characters, because the special system of Chinese numerals, those symbols are not the Chinese characters. So they had two systems to answer your question. Okay, so now I want to talk about a mathematician called Liu Hui, Liuhui. He was born in 225 and he died in 295. He added his own mathematical proofs and republished the work, the Jiujiang Suanshu, meaning the 9 chapters of the mathematical words, in 263 AD. So the original authors of the 9 chapters of the mathematical art lived between 1050 BCE and the 2nd century BCE. But in 263 AD, okay, so in the 2nd century AD, a guy called Liu Hui will edit the manual and will add his own mathematical proof to it. And so it was about 1,300 years after the mathematical Shankao gave his proof for what is called the Pythagorean theorem, or the Câu Cụ Tinh Lý in Chinese. And it has been put in chapter 9, that is the extant copy that we have nowadays. Okay, I would like to read an excerpt from the preface written by Liu Hui from his edition of 263 AD. When the Duke of Zhou set up the rules for ceremonies, 9 branches of mathematics were emerged, which eventually developed to the 9 chapters of the mathematical art. The brutal emperor Qin Shi Huang burned books in 213 BCE, damaging many classical books, including the 9 chapters of the mathematical arts. Later, during the Han Dynasty, Chang Tsang and Geng Shaochang were famous for their mathematical skills. Chang Tsang and others rearranged and edited the 9 chapters of mathematical art based on the damaged original text. Okay. From here, do you have question? Okay, no question. I would take the next 2 minutes
Yes,
to talk.
I do have one. I do have one.
Okay,
so this is the Warring States period?
263 AD. No, it's about in the Han Dynasty. If you're speaking of Liu Hui.
No, I'm talking about the destruction.
Yes, well, 213 BCE was the first decade of the empire. I would like to remind you that the first Chinese empire has been created in 221 BCE. So the famous brutal, or the infamous brutal Qin Shi Huangdi was the first emperor of China, and he burned a lot of books because he was not happy that the scholars was opposing his tyrannical proclivity. And during that 213 BCE book burning, that is called in Chinese. Okay, question: did the Chinese study the irrational numbers such as pi or golden ratio? Pi is known in the Zhujiang Zhuangsu. The golden ratio has been discovered during the Han Dynasty. And Liu Hui, precisely, in the Zhujiang Suanshu, the 9 chapters for the mathematical art, they discovered the formula for the volume of a sphere using pi precisely. But the formal proof has been given by Liu Hui only in 263 AD, because the authors were capable to use the formula, but without a formal proof, which has been given later by the editor Liu Hui in 263 AD, okay, and not during the burning of the book. 4th century before, in 213 BCE. That was the moment of the burning of the book. Okay, that being said, I want to mention a brilliant, a complete translation. Okay, that's truly a first. In 1999, we got the first English complete translation of the Zhujiang Suanshu. by 2 Chinese and 1 Australian, or 2 Australian, because the guy who is from Chinese ancestry, I think he's Australian too. So the 3 translators of the 9 chapters of the mathematical art published by the Beijing Science Press and the Oxford University Press in 1999 were Professor Sheng Kangsheng. Sheng, S-H-E-N, is his family name, from the Department of Mathematics at the College of Natural Sciences of Zhejiang University in mainland China, and by Professor John Crossley from the School of Computer Science and Software Engineering at the Monash University at Melbourne, and by Professor Anthony Lun, Department of Mathematics and Statistics, also at Monash University, Melbourne. Okay. Oh, I make a mistake. It was not Liu Hui in 263 AD who gave the formal proof for the formula of the volume of a sphere, but rather Zhu Chongzhi, Zhu, Z-U, his family name, Chongzhi, C-H-O-N-G, Z-H-I, and his son Zhu Geng, Z-U, his family name, Geng, G-E-N-G, in 250 years after, for the demonstration for the formula of the volume of a sphere. Okay, and let's not forget that I just want to focus on the 9 chapters of the mathematical arts. If you want to know more, you can go on internet and you write the 10 classics of mathematics from China, and you will get the all the 9 classics on mathematics from the Chinese. And now I want to keep on the subject a little bit related to mathematics, but also in music. So before I go to the second subject, do you have questions? Okay, if you don't have questions, I will go to the second part that I have to admit I like more, because it's related to music, but you will see that you will also have mathematics in that. So I would like to start with some biological considerations, okay? We have a neurological apparatus of our inner ears capable to hear sounds from 25 hertz to 20,000 hertz, okay? So you all know that the hertz indicates the number of vibration per second, so the frequency. But our brains are only capable to truly discriminate and attribute emotional meanings to sounds between 25 hertz to 5,000 hertz. So you would not be surprised, for example, probably you all know that on a full piano keyboard having 88 keys, the range is from C1, corresponding to 32.71 hertz, to C8, meaning 7 octaves higher in pitch, vibrating at 4,186 hertz, all right? So it's about in the range from 25 to 5,000, within which our brain is capable to discriminate and attribute emotional meanings to the sound. And why do I speak of that? Because I would like to talk about what is, it's a little bit about Pythagoras today, because the first subject was Pythagoras and his Chinese equivalent. And the second subject is the Pythagorean comma and the Chinese equivalent, and the Chinese solution to that, which resemble to the Western solution and happening almost at the same time. It's incredible. So the Chinese, what is called the Pythagorean comma is called by the Chinese Huangzhong, cannot be restored. Okay, Huangzhong is the name of a fundamental note. Before going to the Pythagorean comma itself, I would like to talk about sounds. Okay, all sound existing in nature, and not only music, is composed by what is called a harmonic series. And that harmonic series is composed by a base, that is heard by us, and that bass is called the fundamental note, and that fundamental note vibrate at a certain frequency, of course. But with that fundamental note, we have what we call overtones, overtones with an S, because the fundamental note is only one note, but the overtones is with an S because the overtones is a superposition of frequencies not directly heard, but contributing indirectly to the richness of the sound. What the scientists discover is that with the fundamental note as foundation, the first layer of overtones is made of the frequency at the next octave. And the second layer of the overtones is made of the frequencies at the fifth. And after that, you have a layer at the next octave. And after you have at the fourth, and after you have at the major third, etc. Okay, so a natural sound in nature would have the fundamental plus everything that is in the harmonic series. That is what the fancy word or the fancy sound for a sound is, a harmonic series. And the first scientific study concerning the interaction of the overtones with the fundamental note has been done by Hermann von Helmholtz, Helmholtz, and he was born in 1821 and he died in 1894. And we all know that some sounds are pleasing to us and some sounds are jarring to us, okay? And the sound that are pleasing to us are called the harmonic interval or the stable interval. And here I go back a little bit to the Greeks. If you take a string, you know that if you divide the string in two and you make vibrate the half of the string, you would have the harmonic at what we call an octave, okay? And that is called a perfect interval because the whole string with the sound of the whole string with the sound of half of the string is particularly pleasing to our ear. That's why it's called the perfect interval. There's only another one who is also a perfect consonant interval. Okay, so I should start with the consonant interval or the dissonant interval. So we have many consonant intervals, but there's only two consonant intervals who are qualified as being perfect, the octave and the fifth. And the fifth is when we make vibrate the string at a proportion of 3 to 2. Sometimes you can say in the reverse, 2 to 3 is the same, to say 3 to 2 or 2 to 3. So those are the two perfect intervals. You have the second interval or the seventh interval who are dissonant intervals, and you have three other consonant intervals, which are the third, the fourth, and the sixth, and but they are not perfect consonant intervals. And of course, let's not forget that the note sounding with the same is called the union, but it's not an interval because it's the same note, simply. It's a detail, but sometimes it's good to say it. Okay, the Pythagorean comma, what is it? The Greek, they discover that they chose the fifth as their perfect interval. Okay, the perfect consonant interval, meaning the proportion of 3 to 2. But what they realize is that they cannot go back exactly to the same octave. And so it can be a little bit difficult to transpose melodies or to make instruments. I will give you the explanation by going to the solution first, okay? The solution is called the 12 TET. 12 TET means tuning equal temperament. Meaning that if you have a string from C1 to C2, for example, you have a jump of 2, okay? Because that's an octave. And how would you divide that string would make the different semitones equal. And if, for example, let's go to a piano from C1 to C8, for example. if you start a C1 at I would not give the numbers after the dot. Okay, it's too detailed. C1 is 33. Okay, to CA is 4186 hertz. If you divide that range of frequencies in 12 exactly, you would have C1 at 33, C2 at 65, C3 at 130, C4 at 261, C5 at 523, C6 at 1046, C7 at 2093, and C8 at 4186. Okay, so you would have an equal interval from one octave to the other, making 7 jump from C1 to C8. In the Pythagorean system, if you jump by 1.5, okay, because the proportion of 3 to 2 is 1.5, well, you will not go back exactly one octave, because if you go, for example, you start at C1s as usual at 33 hertz. If you jump by 1.5, you wouldn't get 49. After that, you wouldn't get 73. You will get 110, 165, 248, 372, and etc. 558, 838, 1257, 1886, 2829, and 4242. So you don't go exactly to the next octave. So the Pythagorean comma is the little difference in terms of frequency at the end that you see. When you go by octave, the last one at C8 is 4186 hertz. And when you go by jump at 1.5, the Pythagorean tuning, you will end up at 43 hertz, so 4243 hertz. So you see that there's a small difference in vibration between 4186 hertz and 4243 hertz. Okay, that small difference in vibration is what is called the comma. Okay, the comma, you can say the difference if you want. Okay, so that is the difference, and that it gives to what is called an enharmonic note, meaning the note having the same name. But if you have a very fine ear, you will see that small difference between 4186 hertz and 4243 hertz. And the reason why the people managed to go to the 12 tuning equal temperament rather than keeping the Pythagorean system is because it caused a lot of problems in the making of instruments. And two, the transposition is not as easy than with the 12 tuning equal temperament. And what happened is that in China, there is a guy named Zhu Zaiyu, Zhu, who was a prince of the Ming dynasty, who found the solution to the problem, to what is called in the West the Pythagorean system, or Huangchong cannot be restored if we use the Chinese expression. And I would like to read a little text concerning that guy. Do you have a question about the Pythagorean comma? Because I realize that it's not necessarily a subject that can be understood so easily, so don't be shy.
The music, I was going to say the music we use today, isn't it based on what they call equal tempered?
Yes, the tuning system nowadays is on the equal temper, and it has been first suggested by the father of Galileo Galilei, and he was Vincenzo Galilei, and it has been systematized by a guy named Simon Stevin, Stevin, and it has been published in the West in 1585. And the Chinese guy, Zhu Zaiyu, published his solution in 1584. Okay, so it's, for me, it's at the same time. And completely independently from each other.
So my question was, so is when you were talking about the difference in the hertz, is it the 4243 that's slightly more pleasing than the 4186? Is that what you were saying?
The two are pleasing, but however, it's easier with the 4243, which is a 12 equal temperament, the 12 tuning equal temperament system, to make the transposition from one melody to the other, or to make the corresponding from one instrument to the other. That was the big revolution.
Okay.
Because, you know, 4186, 4243, you know, you need to have a very sophisticated and fine ear to perceive really the difference. But if you play with two different instruments that which needed fine tuning, there you will see the small jarring that is solved by the 12 TET system. So it has been devised because of the makers of instrument, and also by the mathematicians, because they were interested by the fact that they cannot restore the octave, or as the Chinese said, Huangzhong cannot be restored. Okay, because Huangzhong is the Chinese name for the fundamental note, the C1, if you want. Okay, so I would like, if are there other questions? If not, I would read a little stuff about the Chinese guy.
I have a question about the fundamental note.
Okay.
Is there like an example in nature that that gives us that note?
Well, in nature, all sounds are always a harmonic series. Okay. The fundamental note, it's because of us that we can isolate the note by making a piano, for example. But even on a piano, you have a harmonic series, but we can isolate the fundamental note. For example, when you listen to a bird singing, okay, or even the sound of a drop of waters on a leaf or on the ground, what you perceive at the first layer, if you want, is the fundamental note. That is what you can hear directly by your inner ear apparatus, the cochlea, combined with your brain. But there is a superposition of layers of harmonics that is called the overtones. And that series of overtones are not directly heard by you, but it contributes indirectly to the richness of the sound. So when you hear a sound in nature, it's never a fundamental. Well, you're right, it's a fundamental, but that fundamental is enriched by the layers of overtones.
Okay.
Okay, and if you remember that overtones, the first layer is the octave. After that, you have a fifth. After that, you have the next octave. After that, you have a fourth. And after that, you have a third major. And those are the first 5 layers of the overtone, adding to the richness of the fundamental that you heard directly. And if you want technical details, go to read Herman van Helmholtz, not Van, but von Helmholtz. And Herman van Helmholtz was the first scientist having explained that phenomenon of the fundamentals in association with the overtones. Okay, if there are no other questions, I want to read the stuff about the Zhu Zaiyu, the Chinese guy who gave the solution to the Pythagorean comma. Okay, well, it's not only about him, it's a text that I will read. So the study of harmony in both ancient East and West was occasionally related to the belief of the harmonic consonance between heaven and earth. The Pythagoreans discovered that the ratio 2:3 between 2 music tones give a pleasant sound and thus resembles the harmonic echo between heaven and earth. So the notion of harmony between heaven and earth is not only a Chinese notion, it's also a Greek notion. Similarly, the ancient Chinese literature, the connection between music and the cosmos, 2 to 3, was regarded as the interval of harmony and symbolizes the reverberation between heaven and earth, And 2 was regarded as a number of Earth, because 2 was regarded as a number of Earth for a very simple reason, okay? Because if you need to know the area of a surface, you need one side and the other side. That's why 2 is seen as the number of Earth. And 3 represented the 3 points that form the sky. Why 3 points for the sky? Because when you look at the sky from the Earth, you have the horizon, at one point. You have the zenith, which is the point just above your head, and you have any other point in the celestial sphere. That is the 3rd point. Okay, so that's why for the Chinese, 3 symbolizes the heaven or the sky. Starting from the period of the Han Dynasty, 206 BCE to 220 AD, each lunar month was associated with one musical pitch, and the musical pitch in Chinese is Lu. As people, and here Lu, the character for Lu, on the left side you have the character for moving, and from the right side you have the character for painting brush or writing brush. So why Lu, which is a musical pitch, is related to a moving writing brush? Because of the notion of harmony. Okay, so when you write with a writing brush, there is a harmony flowing. And when you listen to music, there is also a harmony flowing. That's why there is the notion of moving a brush related paradoxically to music. But the 2 are combined or related with the higher notion of harmony. So as people believe that music was an intangible link between humans and heaven, during each month, all ritual performances were carried out in the specific Lu assigned to the month. The calculation of musical pitches in ancient China can be traced back to the earliest written form in the books of Quan. So Quan was a guy who was a prime minister of the state of Qi, and Quan was born in 720 and he died in BCE, of course, and he died in 645 BCE. And the other guy who wrote the second famous books on many things, but also on music, was Lu Puwei, and Lu Puwei died in 235 BCE. And according to some scandal mongers, he was the true father of the first emperor. But that is the detail. So the concept of Lu, which consists of 12 tones that make up the chromatic series, had long been used in ceremonial rituals ever since the Shang-Zhou dynasty. Once again, the Shang dynasty, 1600 BCE to 1046 BCE, and the Zhou dynasty, 1046 BCE to 256 BCE in ancient China, with the fundamental note, once again called Huang Zhong, just like the C1 in today's standard chromatic scale. Okay, if we use the full piano keyboard, starting with C1. However, a tuning problem occurs. In the traditional Chinese music theory literature, such problem is referred to as the Huang Zhong cannot be restored, okay? What the Westerner call the Pythagorean comma. If one tunes the 12 notes of the chromatic scale in perfect fifths, okay, which is the solution by Pythagoras in perfect fifths, the 13th note relative to the fundamental note, which is supposed to be an exact octave higher than the fundamental note, is actually a bit higher than expected, okay? So when I gave the practical example of C8 on a full piano keyboard, you have the slight difference between 4186 Hertz and 44,243 Hertz. Similarly, there exists an ancient Greek counterpart to the tuning problem, commonly referred to as the Pythagorean comma or the Pythagorean tuning system. The Huang Zhong cannot be restored problem, or the Pythagorean comma, was not resolved until the establishment of a new tuning system, the 12th tone equal temperament, okay, equal temperament, or TET. The equal temperament tuning system is constructed via dividing an octave into 12 equal parts, each corresponding to a note in the chromatic scale using 2 exponent 1/12 specific ratio defined using the notion of irrationality. In other words, the system cannot do without the discovery of irrational numbers. You know, I think that all you guys know that Pythagoras has a special allergy to irrational numbers. And apparently one of his disciples has been thrown to the sea because he insisted on the reality of irrational numbers. Because for Pythagoras, the true harmony of the universe can only be symbolized by integers and not by irrational numbers, or maybe it's better to say by fraction. Okay, such an advancement in mathematics was made almost simultaneously in the East and in the West, as with the emergence of the equal temperament system. In the history of the Chinese music theory literature, Zhu Zaiyu, he was born in 1536 and he died in 1611, was the first person to come up with an exact mathematical formula that gives the system of 12 equally tempered tones, approximately around 1581. I think it's the same year that Vincenzo Galilei proposed the idea of the 12 equal temperament system. So Zhu Zaiyu was a Ming dynasty Chinese scholar, musician, and poet. And secondarily, he was also a member of the imperial family. His areas of research included mathematics, astronomy, meteorology, music theory, choreography, calligraphy, etc. He also created musical instruments, composed songs, and wrote poems. Born into a noble family, etc., etc. After all, the rest is not really important. Okay, I pass to the next paragraph. The fundamental pitch that generates all the other 11 pitch is referred as to the Huangzhong in Zhu's work. And though being the first person in ancient Chinese history to propose a theory that is analogous to today equals temperament tuning system, Zhu did not invent the concept of Huangzhong. Okay, so Huangzhong has appeared at the beginning of the Chinese musical theory when I said that Guangzi, the guy from the 7th century BCE, was the first to write about the musical notation. So the notion of Huangzhong was much before Zhu Zaiyu, by practically more than 22 centuries. Okay. Okay, now, but maybe the part that is more important for you. Zhu's definition of the Huangzhong, on the other hand, is slightly different from his predecessors. Instead of defining the length of Huangzhong as 9 cun, okay, a cun is about 25, 2.5 centimeters. Okay, so it's more or less equal to an inch. Okay, but not exactly 2.5. An inch, if I remember, is 2.54 centimeters. So for Zhu, a Huangzhong is 9 cun. The Huangzhong traditionally, is 9 cun, and Zhu Huangzhong is 1 chu or 10 cun. Also, so one more cun, 10 cun. His fixed Huangzhong would correspond to today's concert pitch E5, meaning 650 hertz. In his work, Lü Lü Qing Yi, meaning the pitch temperament system, we can translate like that. Zhu gives the following formula that defines his new system. The new law for density rate, or equivalent to its Western counterpart, the equal temperament system. The length of each of the fundamental pitch is equal to 12 exponent minus 1/12, the fraction 1/12, multiplied by L. So the length of the fundamental pitch, Huangzhong, is defined as 1 chu. So in his book, Zhu gives an illustration of the relationship between the 12 pitches via a picture with the explanation according to that formula. And if you look at the image, it's resembled to 12 pipes, and you have the highest pipes on the left and the shortest pipes on the right. Okay, so it was simply an illustration of the machine that would make the sound of the 12 pitches of the 12 tuning equal temperament, meaning the practical realization of this theory. And from that moment, like in the West, the instrument has been made according to the new system and not according to the old system that in the West is called the Pythagorean system, and the 12 tuning equal temperament system, or in the Chinese word, the Lu Xin Fa, the new method for tuning the pitches, which is the equivalent to the 12 tuning equal temperament. So that's all for Zhu Zaiyu, and I would like to finish my little presentation by some more metaphysical consideration. But before I go into my weakness, which is metaphysical consideration, do you have technical question for what I just said?
I guess I have one question regarding Vincenzo Galilei and how do I pronounce it? Zhu Zaiyu?
Zhu Zaiyu, yes.
Okay. I know that Vincenzo's formula involved taking a baseline of any given length as a string and then multiplying it by like 18/17 as a fraction, and continuously doing 18/17, all like continuously replicating that equally to generate his octave. Kepler took aim at that actually in his harmonies quite violently, directly. But I'm curious, was there a similar fraction used by Zhu Zaiyu, or was he using a different fraction for his equal tempering when he built up his 12-toned scale?
What he made that he was inspired by the fact that already in the Chinese tradition, the basic Huang Chong pipe was 9 Zun, okay, and and from that he would make some calculation giving him the fraction 1/12, because you know that the basic reasoning is that from one octave to the other you have a jump of a factor of 2, right? And let's not forget that in ancient China, the factor, there was 12 notes of the chromatic scale. So he needed to make the calculation to have the exact number to make it, to make the physical pitches, okay? He decided for the first pitch as a Huangzhong, that the fundamental note, to be 12, to be 10 Zun. So he needed the proportion for the next 11 one. Okay, so since there are 12 notes, and since the octave is a jump of a factor of 2, he needed to make the calculation for the square root, the 12 square root of 2. So, and you know that 12 square root of 2 is 1.059, okay, just to make a short answer. And since he knows that he wouldn't have to make a difference of about 6% in terms of frequency from one pitch to the other, from that notion of 1.059, which is a solution, the mathematical solution to the 12 root of 2, he's capable to calculate that from one pipe to the other, you need a difference of 1.059, or if you want 5.9% higher. So he would do it accordingly.
Okay, thank you.
And that's his formula, okay? L is equal to 2 exponent 1/12 times L to the start. So if you want the first one, the first pipe corresponding to Huang Chong pitch a 10 sun. The next one would be 5.9% higher, and so proportionally shorter. And the next one would be 5.9% shorter, which is a solution by the 12 root of 2, which is 1.059. Okay, while the 5.9% higher in pitch or shorter in the pipe.
Okay.
Matt, the difference 18 over 17 gives 1.05882. Well, the 12th root with the 12th root of 2 gives 1.0534. No, sorry. What you said it yourself, 1.059463, etc. So it's close enough. But 18 over 17, if you take that and take it to the 12th power, you're pretty far off from 2. You're at 1.985, which is pretty far off from 2. You definitely hear the difference.
Yeah.
It's the same. It's about the same. It's slightly less than the Pythagorean comma. No, actually, it's about the same size as the Pythagorean comma. So a quick first approximation, 18 over 17 works, but it's not good enough.
Yeah, but it's not so bad because I have my calculator just in front of me. 18 on 17 is 1.058823. Okay, so if you 1.0588, it's if you round it up, it's equal to 1.059. So I would say that the Vincenzo Galileo solution is very close to Zhu Zaiyu solution, in my understanding.
And the advantage is that you don't have to work with roots.
Yeah, that's right. That's right.
So it's Pythagorean.
Yes, exactly. I think that he has been checked by the ghost of Pythagoras. No irrational numbers in my presence. So that being said, okay. Other question on that technical rules and the technical stuff?
It seems to me like even that's not, well, it's not perfect. Like we don't know a perfect way of doing it yet.
Yes, I think that your comment is very brilliant because that's right. The solution that we have nowadays, the 12 TET or the 12 tuning equal temperament, is one interesting solution, but it's not the ultimate exactly. And you have the systems that divide the factor 2 from one octave to the other. You have completely one system, okay, which divide that interval by 19, by 42, by 96, by 72, okay? You have that kind of stuff, but those are, let's say, marginal solutions that are not used. But you're very right, okay? It's not the ultimate solution, the 12 TET solution, but that is the consensus solution that is accepted for now.
Yeah. Yeah, like we're all using some kind of base kind of frequency, which it's like almost like the lowest frequency, and then we keep dividing that. I think of what if we use the base as like the highest frequency we can, I don't know if we can imagine or that we can hear or that we're comfortable with, and then divide that. Like, or no, divide the highest frequency into lower frequencies.
Yeah,
like,
that is okay.
And then maybe even if that's not perfect, we can take the averages of those two or something. I don't know.
Yeah, but what you say, what is interesting for me in what you said, that we have to take into account our human nature. Okay, let's not forget that we can only discriminate and attribute emotional meaning for the sound between roughly 25 hertz and 5,000 hertz. Okay.
Yeah, the 5,000. Yeah, I was kind of shocked. I thought it would be a little higher than that, but what you said is it's the emotional response.
Exact. Technically, our cochlea, our inner ears, are capable to hear till 20,000 hertz. but it would not have, we would not have a discrimination and emotional differences beyond the range of 5,000 hertz. It would be jarring sounds that it would not be music. So I would say that's the ultimate limit to us, okay, our own human body.
Only God knows the right way, maybe.
I suppose that is the right conclusion for now.
Yeah, for now.
Okay. Other questions? Okay.
Are we still in the lecture mode, or are we in Q&A mode?
Yes, let's go for the Q&A mode. Well, I have a small stuff to say maybe in 10 minutes, but okay. If you have other questions about what we just talked, it's okay too.
I'll withhold and wait.
Okay. Okay, so I think that I can go to some of my metaphysical rant, and after that we can go to the Q&A questions maybe.
Mm-hmm.
Okay, because I was a little bit inspired by the two presentations by John Plates and by Dr. Claridge on time, and on the fact that in the Timaeus by Plato, time is a moving image of eternity. And let's not forget that in the presentation of John Place, and I'm happy that John is here today, he's talking about the thinking or the metaphysical and mathematical and scientific reflections about action at a distance or direct contact, right? And since we are speaking of music, of harmony, and of mathematics today, I thought that it would be interesting to have a small metaphysical conclusion. Let's not forget that when Kepler proposed his epistemology in Harmonici Mundi, he advanced the idea of harmony precisely, okay? That the sentence I love, that you have harmonic proportions as expressed in the immaterial and non-localized mode, and the harmonic proportions, okay, the key words are harmonic proportions as expressed in the material, measure, and localized mode. And it's related to John Place's presentation on the action at distance and music and mathematics and harmony precisely. And after mentioning Kepler, I want to remind everyone that one of the naturalists of the 6th, 7th century BCE in Greece, Anaximander, was advancing the idea of aperon, okay, A-P-E-I-R-O-N, and that aperon is what is called the infinite or the boundless. And why I want to mention aperon? Because it's a lot about what is called by David Bohm, and I got a question last week about by David Bohm about something that reminds incredibly Plato's definition that time is a moving image of eternity. The equivalent by David Bohm that time is a moving image of eternity is the whole, is the reality is a wholeness in hollow movement, okay? Reality is wholeness in hollow movement, and that reality is wholeness in hollow movement. It's less poetic than time is a moving image of eternity, but for me, it's exactly the same. Because let's not forget that in David Bohm's explicate order, it corresponds exactly to doxa or to logotrigram, the phenomenal manifestation. And the implicate order corresponds exactly to episteme, or transcendental knowledge, or the three timeless form of beauty, goodness, and truth. And when Plato say that time is moving image of eternity, David Bohm say the same thing by saying that reality is the wholeness in hollow movement. And let's not forget that reality is something that has being, meaning that something that has an independent existence, not related to an observer, okay? And I would say that it brings back a little bit to the quest of what is reality, because we are now in a phase of science that most people would rely on the performance and efficiency of the mathematical formulas, but there is a kind of loss of the quest for what is reality. A little bit when I talked at the beginning of my speech, of my presentation, that in China, they would go from a top-down epistemology, going first to the 3D, to the 2D, to the 1D and to the dot, rather than starting with the imaginary stuff. And the apeiron or Anaximander for me is precisely that, I would say, that substance that can be the medium for action at distance, the same than time is a moving image of eternity, or substance if effective cause, and effective cause is substance, okay? So that is the foundational substance, being, reality, which is at the net, if you want, that would make possible the correlation between the harmonic proportions of immaterial and non-localized mode, and the harmonic proportions in material and localized mode. And I will take 5 more minutes to talk about a small Upanishad that is extraordinary, and you will see that it's about wholeness. And I would say that the Greek equivalent to that Upanishad is the Platonic dialogue called the Eptiphro, okay? Because the Eptiphro is the first of 7 dialogues that, in my opinion, is the Greek or the Western explanation of ultimate reality in terms of epistemology. Because the subject of the Eptiphro is precisely wholeness, okay? Most of the time, it would be explained as holiness, but I think that holiness is another word for wholeness. And after the Eptiphro, you have the famous 3 about basic epistemology. The theatises, talking about the 6 layers of epistemological growth, especially 1 to 3. After that, you have the statesman, and the sophist, I'm sorry, the statesman. So you have Eptiphro, theatises, sophist, statesman, and the next 3 will be more about episteme, okay? Crito, the Phaedo, and Apology of Socrates. So why I want to talk about those 7, because those 7 are about epistemology. And even if today I was talking about maths and music and tuning systems, in reality, everything that each time I talk is always about epistemology. And that's why I want to finish with a metaphysical conclusion. And I want to say that if you want to have a perfect explanation by the Greek tradition of general epistemology, go back to those 7 dialogues, the Eptiphro, the theatises, the sophist, the statesman, the Crito, the Phaedo, and the Apology of Socrates. And we discussed the Phaedo not long ago. And the Phaedo is truly talking about what Anaximander was calling the apeiron, and that Plato is, when he talked about the time is a moving image of eternity, and that David Bohm, when he was talking about the fact that the reality is the wholeness in hollow movement. And I take really 3 minutes about the Upanishad. The Upanishad, Ishavasya Upanishad, and it's my translation. Ishavasya Upanishad, I would translate it as the timeless poem on the whole. And it's not very long, so it starts with Om, which is the cosmic sound, okay? And that Om, the cosmic sound, also reflect the epistemological growth that you can see as the 6 layers of the mind. And it starts by Purna Ada. Purnam means the whole. Ada meaning the upper trigrams. So it's translated by that is whole. And after that, you have Purnam Idam. So once again, Purnam is the whole, but Idam is the phenomenal reality. So this is whole, that is whole, this is whole. And I wouldn't finish just in English. The whole, this whole comes from that whole. And even if you remove this whole from that whole is still whole, okay? So that very old Upanishad is saying exactly the same than Plato when he said time is a moving image of eternity, or when Larouche said that substance is effective cause, or effective cause is substance, or when David Bohm said that reality is wholeness in hollow movement, or when the Chinese said the interpenetration of the lower trigram and the upper trigram, or I rather said the upper trigram and the inner and the lower trigram, because in the Chinese perspective is always top down, as in the Greek Chinese is always top down. And I stop here. Thanks for your attention.
That's lovely. The epistemological overture was was very well placed. That was perfect. And that was there the whole time, right? I mean, even though that was sort of the punchline that you built towards, that was there present and could be. I think when people rewatch this or watch this online, they should think about how that core idea that you just expressed was sort of the unifying theme, shaping each of the elements that you brought on from the beginning that could be treated as particular words, on a timeline, but it's not at all. They're all infused with value because it's to set the foundation of our minds to understand that higher metaphysical punchline. So that's good. Thank you. At this point, let's open up for some dialogue, some questions. I usually ask people to put their name in the chat box like usual, and you could do that. Otherwise, if you want to raise your digital hand, you can do that too. Or Quan kind of likes a bit of a chaos factor sometimes. So if you want to just pop your voice into the mix, you can do that as well. I actually have a little question. It's not so much on the metaphysics, but it's more, and maybe you said it and perhaps I didn't catch it, but I know many writers from the ancients to the more recent times described the relationship of various modes and emotional tones and their political effects. Obviously, Aristotle wrote about this, but many have. Are there similar studies and writings in the Chinese texts as well, or the ancient texts or more recent, that also described investigations into the emotional corollaries between certain modes? Like in Greece, you had the Phrygian, the Dorian, all these things that had certain.
The Mixolydian.
Huh?
No, okay, finish your question.
And that had certain different types of feelings that would be evoked in the human soul, of elevation. Times of war, you want to have a certain type of tonality. In times of like somberness, you want to have a different tonality. If you want to get people excited as a speaker, you want to have a certain type of musical environment. So yeah, are there similar studies in China on that?
Yes. And it has been, there's a classic of the Chinese classic that has been lost, and it was the classic of music. However, I'm sure that the notions of the classics of music has been transmitted in all the old books, because as the Greek has, for example, the Locrian mode for what is more somber, of the Ionian mode or the Lydian mode or Mixolydian mode for what would be called major nowadays. The Chinese too have the same, because for example, that for the Phrygian mode, it would start with the note E, For the Dorian mode, it would start with the note the D, and you know perfectly that in musical theory, why you feel emotionally different is because the semitones are not placed exactly at the same place, depending if you start with a C, a D, a E, or an A. Okay, I think you understand that musical theory. So in China, it's the same. Let's not forget that in the book of Quan in the 7th century BCE, he was talking about the 12 notes of the chromatic scale. And at the same, we can have, what is a scale after all? Okay, a scale is a pattern of intervals. Okay, because as I said, depending that on what note you start, the pattern of intervals is a little bit different. And because of that little bit difference from the pattern of intervals, it would have an impact on our perception, emotionally speaking. And the Chinese, the same, they would have different names than Mixolydian, Lydian, Frisian, or Locrian, etc. But they also have scale that would start on Huangzhou, on Lingzhou, on Taizu, on Nanzhou, on Huangzhou Qing, etc. Those are the Chinese names for the note corresponding to Frisian, Locrian, Mixolydian, Lydian, Dorian, etc. So, and let's not forget that for one of the major reasons of music, especially ceremonial music in ancient China, is that when you play a music that is harmonious, you are inviting the heavenly gods to descend and to have their beneficial effects on earth. Okay, so when you have a music that would be qualified as evil or sensual or sexual, you would invite demons to come to earth. So if you read Confucius, so he would call the music of the principality of Zhou as lascivious, as sexual, and he was strongly disapproving of that music because in the religious belief of ancient China, if you play, let's say, the equivalent of rock and roll, you would invite the demons to come to earth, and it was not something that was approved.
Interesting. The do you have any videos or anything that you could send out that we could share that could give people demos, demonstrations of these various modes in China?
I would suggest if we have time, there is a reconstitution of music. Let me 2 seconds.
I could allow you to share something if you want.
Yes, because there is because speaking of court music that is inviting the divine gods to descend rather than the demons or the monsters, I will send to you personal chat, not chat, but Telegram stuff, Matt, a stuff that is called Music of Zhu, and it's not very long, it's 4 minutes, and you will see that the tone is noble, okay? And it's, okay, I just sent it to you, Matt.
Yeah, I'm opening it now, and I will share it in 2 seconds. Just opening the screen. Excellent.
So I would say that that short excerpt can give you an idea what was favored at the court in the scholar class. Okay, so you have the kind of music that would elevate your soul, that would bring peace in your mind, in your heart, and not of that jarring or disruptive music. So I would say that what we just heard is a reconstitution of the ideal of the scholar class in ancient China, and I would say even of the scholars class nowadays.
Mm. Well, yeah, and it definitely reflects the concepts that we've been reading about on the Wednesday night readings of the harmony of interests. That was very much something that shaped an idea of win-win cooperation as the basis of value in deciding economic policy from the standpoint of the American system leadership. And to see that as well, you had the idea of the harmony of the state, the harmony of all parts within a nation having to work together in order to create an overall beautiful effect that is good. That's yeah, the role of music plays a very, very, very big part in that. Eh?
Exactly. And I want to add that in ancient China, when a new dynasty replaced an old one, all the musical instruments of the old dynasty are buried within the tombs of that former dynasty, because it was considered that they were not capable to bring down the heavenly spirits to roam the land in the right manner, and the new dynasty would have to cast a whole set of new court instruments and it was part of the state duty of the new dynasty.
But the tuning was the same, right?
Well, the classical tune from the past would be kept on, and the new dynasty would create their own new melodies, But what was considered as nefast or wrong from the old dynasty, that either they did not perform rightly the classical melodies, or they introduced disturbing factors which contributed to the fall of their dynasty.
Interesting.
And in the Analects of Confucius, you have many commands by Confucius or by his entourage about the emotions or the mind set of someone when he is playing a musical instrument. It would express his inner state of mind and soul. And same with calligraphy, okay? You know that Chinese artists never sign their stuff because it would reveal too much of their soul. They would use a seal instead.
That's why they would use the seal. Really?
Yes.
God.
Because when you write and you show your calligraphy, you already showcase to a certain extent your soul and your mind. But when you write with a brush your name, you will reveal more of your soul. So it's better only to put a seal and not writing your name with a brush.
Oh, on that issue, I have a little question. When you brought up the lunar months in the Han Dynasty that would be associated with a musical pitch for each month, but not only that, but that there'd be a motion of the brush also associated with that throughout the chromatic scale, because 12 months, 12 tones makes sense. But could you say a little bit more about like how this informed the brushstrokes of the calligraphers or the painters, or how did that correlate?
Yes, I would say that the guy who, because it's not my explanation, okay, it's the explanation by Zhu Zaiyu. Zhu Zaiyu was the famous philosopher of the Song Dynasty. He was born in 1130 and he died in 1200. So for Zhu Zaiyu, you have Qi and you have Li. Okay, Li is the upper trigram. And let's decompose the word Li. Li, on the left, you have the symbol for a king. Okay, on the right, lower part, you have the symbol for the earth. And on the right, the upper part, you have the symbol for a field. Okay, so a field is the earth that has been organized in the human manner. So the king organized the earth or the soil in a field. And here, epistemologically, the king is not only the social sovereign, the king is also the person who has achieved his epistemological journey. So, and the earth or the soil is not only the ordinary soil, and the field is not only the ordinary field, but it's the soil of our qi that has been organized in the right manner, in a heavenly manner, by the fact that we have achieved our epistemological journey. And when Lu, the pitch, okay, because the character for Lu, pitch, on the left side you have moving, and on the right side you have the brush, okay? So when you make a calligraphy, you are moving your soul, your body, your phenomenal reality in harmony with the king, okay, with the law of the universe. And here you have that epistemological journey as symbolized by king in Li, and Li is principle, okay, and that Li is common to the calligrapher moving his brush and to the musician playing his melody. So it's not a surprise that Lu, the word for pitch used in music, is composed by two stuff related with writing, moving, and the writing brush. So here, writing or making music and composing music or doing anything in your life should be governed by the king, the epistemological journey, starting from your phenomenal reality, the soil, to a structure reality, the feel. Okay, the three elements for Li, the principles.
All right, thank you, Nathan.
Sorry, I don't really have a comment. Just thank you for the music. That was just fantastic. I was gonna, I had a kind of a extraneous thought, but I think it's fine. I was just thinking about how the music of today is always changing, always trying to make something new, or at least superficially on the surface. And but anyway,
on that point,
just continue on. Yeah.
On that point, it is and it isn't at the same time. Like there was a very interesting video. Maybe I could find it on YouTube. I'm not sure if it's appropriate necessarily here, but people can find this, featuring some very talented artists with a few instruments, a keyboard and a few other things, where they just simply take the fourth and the fifth and these very, very basic primitive modes that are at the baseline of the constructions of all popular music since the 1960s. And you could just see that there's actually a very simple set of formulas that invoke certain feelings and that have just been used and recycled in every top 40 song that's been played on radio. Like, I'd say the 50s even, and they go through hundreds of examples of this stuff on their channel.
Yeah,
there is a lack of variation as well.
Right.
It's almost like sophisticated music will never be popular.
Well,
yes,
I don't know. I think it is popular just by its. That was just fantastic music. Just listening to it.
Well, Quan, what do you think about that?
I think that what Kelly said is very interesting, because I would reverse what he said. I would say that if we manage to uplift epistemologically more people, sophisticated music wouldn't become more popular. If by popular we mean the number of people liking it, okay? So if we can only increase the number of people liking high quality, sophisticated music by uplifting epistemologically more people, I think I cannot imagine another solution.
Well, I agree, yeah, but I don't know.
Well, it was out of tremendous respect for the changes that the maybe calamities that would happen in the population, that after a new dynasty or kings would sort of form, that they would bury that, like you were saying, they would bury all the instruments and they would try to create a new relationship with the harmonies that slightly perhaps will bring down the presence of the timelessness more effectively.
Exactly.
Yeah.
Yes, because the political conclusion is that if the former dynasty lost its mandate of heaven, it's because it was less capable or incapable to maintain the harmony between heaven, earth, and man. So there must be something evil in their musical instruments, so they have to be buried, and the new dynasty has the duty to make another new set of court instruments.
Except it may not actually be evil, because there's always a creative principle to the. And I'm the last person to say this because I don't mean chaos, and I have to be careful with myself. But I'm just saying that there is a creative principle that sometimes authority tries to. I've said too much. I'm going down the wrong.
I got a question. Cynthia just found the referenced, or one of the referenced videos that I was talking about, and sent it to me, featuring the banality of popular music and the misuse or the overuse of these basic chords. Quan, do you want me to play it?
Yeah, sure. It would be a contrast with the court music of Zhu.
I think so. Yeah, it's called. Yeah, this group is called the Axis of Awesome. Thank you, Cynthia, for finding this. Can people hear this?
Awesome. And I'm Benny.
Can you hear that?
Yeah.
Okay, 1 second.
Yeah, we've been a comedy rock band for close to 40 years now, and all that time we've never had a hit. And
Yeah, but you guys know why.
Why?
Because we never wrote a 4-chord song.
What's that? What's a 4-chord song, Benny?
Well, if you want all the greatest hits from the past 40 years just use 4 chords. Same 4 chords for every song. It's dead simple to write a pop hit.
Just 4?
Yeah, these 4. Here. 1, 2, 3, 4 chords.
Sorry, let me get
All you
this
need to
straight,
write a-
Chicken Little. What you're trying to say is you can take those 4 chords, repeat them, and pump out every pop song ever. Is that what you're saying?
Yeah.
Fuck off.
Yeah, fuck off, Chicken Little.
Just listen. Do you recognise this?
Yeah, that is Don't Stop Believing by Journey.
It's a great song.
Very original
There's a few more that
song.
fit. Check it out. My life is brilliant. My love is pure. I saw an angel. Of that I'm sure.
Well, that's just 2 songs that are similar. That's not a big
Forever young.
3 songs.
I wanna be forever young. I won't hesitate no more. It cannot wait. I'm yours. This is the way you left me. I'm not pretending. No love, no hope, no glory, no happy ending. 'Cause you were amazing. We did amazing things. If I could, then I would. I'd go wherever you will go. Can you feel the love tonight? And she will be loved. Yeah, she will be loved. Pictures of you, pictures of me, hung upon your wall for the world to see. 'Cause I can't live with or without you. Whenever I fall at your feet, you let your tear.
Am I not pretty enough? Is my heart too...
Double time?
Double time.
When I find myself in times of trouble, Mother Mary comes to me.
Sometimes I feel like I don't have a partner.
That's the way it's gonna be, little darling. We'll go riding on the horses, yeah. No woman, no cry.
There surely is a dream.
I come from a land down under.
Once a jolly swagman kept by a billabong. Take on me.
When I come around,
Take me on.
when I come around.
I'll be gone when you're Say tonight.
Gonna take a lot to drag me away
Break
from
up
you.
your ground.
There's nothing that 100 men or more could ever do.
Help! No more, please!
Play with me.
John's begging for no more. I think people get the idea, though.
Yeah.
Oh, yeah.
Did that hurt your ears, John?
Huh?
Did it hurt your ears?
I feel I'm stupider.
And yet you're wiser too,
Well, I
because
just went
it,
through
it
that
did illustrate
years.
the banality of the formulas that are shaping our popular scene, like our popular culture, which a lot of people take for granted.
And I think that
You mean the
everyone,
banality is taken for granted?
Oh, I guess I misworded that. People don't assume that there's so much banality underlying what they think has value. How about that?
no. True. And we all know that music has the most emotional impacts on humans. Okay, so you can shape very easy the dominant culture within a society with the form of music that is favored, that is well known.
Mm-hmm. Yeah. No, I really appreciated the way that you were able to draw out the Pythagorean comma and its corollaries in China. What was it, that which cannot be restored? I love that.
Huang Chong is written HUANG ZHONG, and that is the name of the fundamental note corresponding to C4.
Excellent. No, that was one of the clearest descriptions of that discontinuity, that discrepancy that I've yet seen. It was very, very efficiently done. Susan Hoffman writes, in every facet of our reality, an approved script has been created that the controllers try to keep us from departing from. If we don't depart from the script, we stay in the boxes they created. Well said, Susie.
Yeah, absolutely. And I repeat myself, okay, but let's not forget, music is probably the art having the most impact on the human beings, because let's not forget that if I would like to take 2 minutes talking to reminding the muses, okay, the 9 muses, because this jump from the lower trigram or from phenomenal reality to the upper trigram to the timeless reality is really by exploring the domain of the 9 muses, okay? And among the 9 muses, Utopy, the muse of music, has probably the most impact, because once again, music has a lot of impact on us, okay? And the other 8, Clio, universal history, Calliope, epic poetry, and let's not forget epic poetry is epos in Greek, okay? And epos in Greek means the good, okay? The poetry extolling the heroes, the people capable of courage, of wisdom, of humanity, of justice. And you have Polyhymnia for sacred poetry, sacred music too. You have Thalia for comedy. You have Melpomene for tragedy. You have Urania for astronomy and mathematics. So it's science. Let's not forget that science, true science. And once again, there is no division between what is called natural science and political sciences, okay, in the epistemological journey, and etc., etc. So I want to insist on that, because how to jump precisely from the phenomenal reality to the timeless reality, it's precisely by going through the domains of the 9 muses, and you have to distinguish between what is imposed by the dominant culture and what would be the good way of the 9 muses to go to the timeless dimension of reality.
Yeah, very good point. John, I see your hand there.
Yes. And this has been an interesting talk, Quan. It's made me think about a number of things. One is that it appears that at key moments in the history of humanity, there has been quite intense communication between different parts of the world, and this includes in the ancient world. And if, assuming that the chronology is correct, you know my opinion that the chronology is often suspect, but assuming the chronology is correct, you have some very fundamental ideas appearing within years of each other in very different parts of the world. So my natural understanding of this is either it's a shared catastrophic experience, but this, or something was invented in one part of the world and then very quickly to move to other parts of the world. And I think in this specific example that you're talking about, the commas, I think it's the second. Now, whether it started in China or in Egypt or some other place, honestly, I would have no idea. And I'm sure you would think it was China. Raj Vedam might have said India, but the point is that clearly there was serious communication taking place between these ancient cultures. I wanted to pick up on Susan Kaufman's comment, in every facet of our reality, an approved script has been created. Well, in science, the word standard model is used. So standard model without any without any additional comments, refers to the standard model of particle physics. But you can have standard models of how muscles work, standard models of how the aurora borealis and aurora australis work. You can have standard models on just about any scientific topic. And yeah, that's exactly what happens. You get these, sometimes they're quite close to what's actually happening in reality. Sometimes they're very far. But it's not so easy necessarily. It's easy to think that it's just the controllers who want to do things this way. I mean, let's face it. We have our controllers, we have our Wikipedia correctors, and so on and so forth. But sometimes it's simply that there's so much historical baggage that to move on to something different is incredibly difficult. If we look at physics, for example, the amount of time and energy invested in mathematical techniques that have been developed over the centuries, working within the existing standard models, assuming that a specific part of physics were to be replaced by a completely different paradigm, that entire mathematical edifice would have to be completely reconstructed. So long as the mathematical edifice for that particular topic of physics is still useful and providing results, sufficient results, the people using it would say, why bother? Why should we go to the trouble of completely redoing our training, rebuilding our machines, redoing our mathematics, and so on and so forth? So it's not just a question of malice on the part of controllers. It's also that there's a
it has a life of its own. It has a force and a life of its own. I was thinking a little bit about in the music industry. Imagine going in and all of a sudden trying to persuade the musical artists and the producers and everything that all of a sudden we can't use that as our standard baseline anymore. They have a freak out, like people. The cognitive dissonance would be astounding.
Yeah.
What do you think of that, Quan?
Well, I think that John is perfectly right, because we often talk, Matt, and that one of my leitmotif is that we have the plutocratic man in us, okay? Because if we don't have that plutocratic man in us, the plutocrats would not be capable to manipulate us, okay? So I'm not bashing ourselves, I'm not bashing our group, but I'm saying that yes, we have to identify the controllers, we have to identify the plutocrats and the people wanting to manipulate us. But our first duty is not a nice word, our first endeavor is our own epistemological development, because if we are epistemologically developed, no one can control us. It's as simple as that.
Our fate is not in our cords, but in ourselves, that we are underlings.
Yes. And it doesn't exclude Matt, that sometimes we have small fights, okay, and it's always about that, okay. It doesn't exclude the fact that we have to identify those plutocrats, that for sure, and their shenanigans. But in my opinion, the main stuff is our own development, our own epistemological development.
Douglas has a question about Rupert Sheldrake. Douglas, do you want to ask your question in a way? I mean, it's not really posed as so much of a question in the chat box.
Sheldrake's hypothesis of morphic
resonance
tends to take that idea that ideas come up in different people in different places at similar times, to the point that you can see even in old experiments on rats, where those who learn an absolutely novel event in one place, then rats done with that same event in another place do it in less time. In other words, the learning is already there, all right? And it's communication on a similar species level, not across species, but there is something there that for which he has received untold amounts of criticism. But as you were saying earlier, these things happen, and we see the evidence of this and yet we're afraid to talk about it in those terms.
So is this a communication? Is this like a communication without actually communicating? Like,
Yeah.
In a telepathic way.
okay.
The idea of Rupert Sheldrake's morphic resonance is that once something has been invented once in the universe, it takes huge amounts of energy to get to that first invention. But subsequent inventions by other people, or in this case, the case that was just mentioned by Douglas Ratz, of doing the same thing, the energy level to reach that new invention is much less than the very first time.
Similar issue he points out in terms of crystal formation. When you first crystallize a compound, it takes far longer and takes far more energy to do that than it does the second time or the third, even in different locations.
Yeah.
It's his evidence. Yes.
So you could think of new platonic forms being created over time.
Well, he's got a TEDx talk that was not particularly popular with the scientist community, but is particularly illuminating in terms of what the politicization of science has done to everything that we think we're studying. And it's still on YouTube if you want to take a look at it, because it's rather not very long.
Yeah, share it. Share it by the chat box or by email. Share it via the chat box here on Zoom or by email.
Okay.
Thanks.
I'll get the link.
Yeah.
All right.
Quan, you have a thought on that, or?
Well, no. Well, it's very interesting. Okay, because if we have time at the end, I would like to read a small stuff by David Bohm, and I'm very happy we are having the discussion now. Okay, because and it's linked to John, what you about on your talk about the action at the distance. Okay, because I would say that harmonic proportions is an intuition by Kepler that would subsume many of the stuff that we are discussing right now.
I recommend a book.
Yeah, sure, of course.
This came out. I don't know how easy.
But you have to speak so loud. Your microphone is so bad.
Still,
it's such a bad microphone. But yeah, we can make you out. We just have to squint our ears.
Hold on. Let me see if I put the sound. Can you hear me better now?
No, but it's okay. We can still hear you. It's intelligible. Go for it. What's the book?
Okay. All right. It's called A New Science of Heaven. It's on plasma physics. The author is Robert Temple, who is actually a very close friend of Rupert Sheldrake and his wife. And Rupert Sheldrake's wife was very involved in music. So she's probably, and I've forgotten her name, she's probably a good person to look up to. I think if you can find her name, I've forgotten it. I think she may have had some stuff on YouTube at some point, or somebody who was a friend of hers gave me stuff that she had done. Anyway, so she's curious, but Robert Temple's book is well worth the read if you can get it. And it's on the Kordylewski clouds, which are plasma clouds, that have finally been proven to exist. They were discovered, I think, in 1954 by Kordylewski, but he didn't have the technology to prove their existence. So they were rediscovered in, I think, 1918, in 2018 or 2019 by a couple of Polish, maybe Hungarian, but I think Polish scientists who were not really interested in their plasma potential, but just in validating. They were astronomers and physicists in validating their existence. And the book is very well documented. I mean, it's practically 50% footnotes. So David Bohm was a very close family friend. Rupert Sheldrake is a close family friend. And so he has a particular feel for the topic. And I think for years, don't quote me, I think he may have been a writer for a lot of top science magazines covering different scientific discoveries and getting them into these magazines. And I think he was also is in and of his own abilities rather a genius of sorts. I think he went to UPenn when he was 16, and then he decided, I don't know what he started studying. He eventually ended up studying Sanskrit for whatever reason. The Sanskrit may actually have musical properties. But anyway, it's well worth a read if you can get a hold of the book. It's not a cheap book. It's like $40, but it's well worth keeping because the footnotes in themselves are going to give you the source material to back up anything that you would say about plasma physics. So that's my contribution.
Can you just say the name of the book one more time? But it's Robert Temple. What's the name of the book?
I believe it's called A New Science of Heaven.
Okay. Thank you. I'm going to order that.
If I'm off a word or two, look it up on Amazon. You'll see it there. It's like $40 now.
Okay.
But well worth getting, well worth reading. Very sciencey, though he says, and somebody like, you guys won't have any problem reading it. For me, since physics isn't my background, it's a challenge. But most people who've read it, if I read it a couple of times, I would get it too. But it's an investment, if you're non-science, of reading it a couple of times. And you'll get a lot out of it. I mean, most of you will do one read and say, wow, this is a great collection of information to have.
Okay. Thank you.
You're welcome.
This one, Helen just wrote in the comment box, necessity is the mother of invention. Kind of true. And then Jerry wrote an interesting response saying, invention is the mother of invention. Also an interesting response. I enjoy that.
The epistemological growth is the mother of invention.
Ah. Checkmate. All right, Susie. All right, I see your hand there, but then I just realized the time, and we're gonna have to close it up after this, so that you get the honor of being the last question. Susie, go for it.
Well, I wanted to ask, who was it that was speaking about the morphic field just a few minutes ago?
That was Doug and John.
Okay. Can somebody email me about that? I really would like to.
Susie,
learn
go to
more.
the chat box. Both Doug and John simultaneously shared the same YouTube link, possibly demonstrating why Sheldrick was right yet again.
Well, there we go.
Plus, I put in a talk that Rupert Sheldrake did at the Electric Universe Conference in Albert in 2013 called Science Set Free. And that one's mind-blowing. It includes a discussion of the constants, such as the speed of light changing over time.
Oh, cool.
His books are actually quite good.
Yes.
On that subject.
All right.
So
cool. Thank you.
Fritzoff Capra is also a good source.
You can actually go to rupertsheldrake.com. All of his stuff is on his site.
Yeah. So what we'll do, I'll make some of these links. I've had people messaging me saying, "Hey, there's often interesting things discussed in the discussion period of these classes, and I never link in the YouTube video these very interesting links. I'm going to try to be better at that, and I'm going to do it this time around. But that being said, Quan, if you could, would you be able to find some celestial harmonic music, some great classics that you could also recommend as a playlist, which I could include for those who want to listen to more Chinese classical music as an introduction? I know that many Western ears are not tuned to this, so it's going to be a fun, I think, door that you're opening, that people can now start actually listening to this with more of an educated mindset. So could you...
I will be absolutely delighted to introduce some stuff which are not only Hong Kong canto pop. Of course.
Very cool. Very appreciated that. All right, Quan, thank you so much for sharing this today. And yeah, this is a great way to round out this science symposium. We're gonna still have more science classes, don't get me wrong, but I think this is a good bookend for this particular thrust that we were under. So everyone, thank you for joining us this Sunday. Thank you, Quan, and see y'all next week.
Thank you, Quan.
Thank you. Ciao.